Hello, this is Mario from Audion. In this video, we will show the Source Power Estimator, available in Audion Editions Industrial and Combined. The Source Power Estimator is a tool that will allow you to estimate the sound power of real sources by performing simulations in a model with SPL measurements as reference. This will yield the sound power in the 8-octave bands from 63 Hz to 8 kHz. This is especially useful for sources that cannot be taken to an acoustic laboratory, and it will work to an extent even if there are several sources active at the same time. The mathematical background of the Source Power Estimator is explained in more detail in Chapter 14.1 of the User Manual. First, we will explain the measurement setup. If possible, try to make SPL measurements with only one active source at a time. Otherwise, even with multiple active sources, the sound power of individual sources can still be estimated to a certain extent, depending on the complexity of the measurement conditions. In general, we recommend various measurement points per active source, between 3 to 5 measurements per source. They should preferably be fairly close to each source, but also not too close in order to avoid near-field effects. So, at a distance equal or slightly greater than the source's largest dimension. Also, and especially with multiple active sources, try to measure in regions mainly affected by one source. If there are multiple active sources, the estimation works best in rooms with low reverberation, since it will make it easier to measure larger spatial variations of SPL. In contrast, if we are in a completely reverberant space, we can expect the SPL to be approximately the same everywhere, which makes it difficult to tell different sources apart. Since you will require SPL measurements, you should measure with a sound level meter rather than with Audion's measurement system. When measuring, remember that you should get the SPL in individual octave bands. Next, you should make an Audion model. This should have the same setup as the measurements, such as the positions of sources and receiver points. This is a model for an actual test case we performed. The sources should be modeled as the right type, whether that is as a point source, line source, or multi-surface source. And in the case of a point source, it should also have an accurate directivity pattern using relative values. You should make as many jobs as there were noise conditions in the room. For example, if you had 3 sources and made measurements with only one on at a time, you will need 3 jobs, each with one active source. But if all 3 sources were on simultaneously, that would be one job with all 3 sources active. If you have Audion Combined, you can also optimize your model with the Genetic Material Optimizer, which will make the source power estimation more accurate as well. For that, you will also need impulse response measurements of the room, additional to the SPL measurements. Just keep in mind that the SPL measurements should be done with the noise sources on and using sound level meters, while the impulse response measurements should be done with the sources off, and you can perform them with Audion's measurement system, which we explain in another video. If you have the impulse response measurements for the Genetic Material Optimizer, you should load those first, since loading them will overwrite previous measured data. Loading the data and using the optimizer is explained in this other video. For the SPL measurements, you can format them in a spreadsheet like this. To assign the measurements to the job, first go to the multipoint response for that job. Here, go to the Simulated versus Measured and Targets tab. Then go to the Context-Sensitive menu and select Open Edit Measured Data File. If you didn't previously load other measured data, you can just directly copy-paste from the spreadsheet. Make sure to save. If you did previously load measurements from impulse responses, you will need to copy the SPL line on each corresponding receiver. However, make sure to only enter the measured data corresponding to the job's active sources. That is, if the job is for source 1 only, then enter the data that was measured with only source 1 active. If you have various jobs, then repeat the procedure, again respecting each job's active sources. When your setup is ready, you can go to the source power estimator by clicking here. In this drop-down menu, you will find the list of applicable jobs. Only jobs with loaded SPL data will appear here. The first number is the job number, and for each one, it shows the number of active sources and the number of receivers with loaded measurements. You can confirm the sources and receivers to use in the 3D view. In this case, I will first calculate for all sources, which are active in job 7. First, you will see the power spectrum of each source. You can scroll through sources with the left and right arrows. You will also notice these error bars. This is how much the power can vary while still resulting in about the same SPL values. To look at the power of all sources in a single octave band, you can go to the All Sources tab. You can then change the octave band with the up and down arrows. You can also compare the measured and simulated SPL values in the Receiver tabs. Again, you can see all octave bands for each receiver or all receivers for each octave band. If you change the job, you can still go back to a previously calculated one. Notice that there is high uncertainty in some of the results. The room where we measured was quite small, so there could have been a few problems. One is that the sound field might not have been diffuse enough at that frequency to properly simulate in Audyon. Also, the SPL was quite uniform across the room, which again can make it hard to tell sources apart. There could even have been some masking effects between sources. Some of these problems will be solved by estimating for only one active source. So I will try estimating for the case where only source 3 was active, which is job 3. Again, the measurements assigned to job 3 were also with only source 3 active. The results now look more reliable. Also, there is documentation for the source we used as source 3, so we can compare. We can export the data by going to the context-sensitive menu, then to ASCII output. When we compare, we can see that the results are quite close. To update your sources with the new calculated sound power values, simply close the window and accept the confirmation. Most of the uncertainty in source power estimations will come from the measurements, the model, and the simulation parameters, but the estimation algorithm itself is quite robust. You will find a summary of the procedure and of best practices in sections 14.4 and 14.5 of the user manual. With that, we conclude this tutorial, and we hope you have found it useful. Good luck!